right, so we have a few more rules that fit these angle properties inside the circles, and then we throw a couple segment ones at you too. Originally, this was part of last class's lesson, but we decided it was a little much, so we removed it. So if you could join me on this front sheet of your note sheet. So I wish this picture was a little bit better, because what I want you to draw instead is a circle in this space right here. And then I want you to draw two chords that obviously do not intersect in the center of the circle. Because what I want you to make sure that you know is that this intersection point is not in the center of the circle. So when it comes time for measuring our angle values, we still have two vertical angles, and that's easy, but because it's not on the center, we can't say that this angle 1 has the same degree measure as this arc measure, because 1 and 2 are the same, but there's no way that this arc measure and this arc measure are the same. You see what I'm talking about? So I like to call this my middle school pizza problem. So you know I spent 11 years teaching middle school at GeoHN Middle School. And I've been a part of more than a few pizza parties. So let me tell you the scenario as I see it, as a teacher's view. Boxes and boxes of pizzas come up and they line them up on the long rectangle table. Are you with me so far? Have you been at a middle school pizza party? Yeah. And all the middle schools are lined up, and the teachers with gloves on and that don't fit were frantically trying to hand out the pizzas. Are you with me so far? And I see the middle schoolers doing this. Because what they're looking at is the fact that very few pizza shops can cut a pizza even. You agree with me? What do you think the middle schoolers are looking at?
Biggest slice.
Where's the biggest slice? And it's always funny when I see some slick dude looking ahead, counting, and then he turns to his buddy and goes, "You want to go like that?" Why would he do that? Because he just figured out which slice he's going to get. No, you go. So this little dude's like, "Aren't you nice? Thank you so much." And he comes up, and if somebody like me is doing the handing out of the pizza, I'll skip a slice, give that dude the big one, and give Mr. Slick the skinny one, and go, "Have a great day." And he's like, "What?" And here's what you can count on. The nice kid, the non-slick kid, I've seen it happen. He turns and he says to his friend, "Oh, do you want me to share? Do you want me to give you some?" Because he recognizes that the guy behind him got a small piece and he got a big piece. And they share. And it's very nice because then everybody gets what they need. Hey, that's what happens here. It's our middle school pizza problem, because this guy gets a little piece of pizza, this guy gets a big piece of pizza, but this guy is Mr. Super Friendly, and he's like, "Hey, do you want to share?" So what we're doing is when we're figuring out the measure of these angles, it's going to be the average of these, and this is angle 1. It's going to be the average of these two arcs. Take a look at where angle 2 is. Angle 2 and angle 2 has the same value, but if you look at their intercepted arcs, they are not the same. So what we're going to do is we're going to come up with the average of those arcs. We're going to add them together, divide by 2, and then these two angles are going to evenly split this area around, this distance around the circle. So we're going to think of that as our classic middle school pizza problem. And 913 is going to help you anytime on the back that you see the arcs intersecting inside the center of the circle, but not on the center of the circle. All right. So now what I want you to do is take a look at 914 and 915. They look very similar. They each have 3 different scenarios of conversation, but one has to do with angles and one has to do with the lengths of the segments. So first let's talk about angles. And let's give ourselves a little bit of a review. When I had a circle and I had a central angle, the measure of that angle x was equal to the measure of the intercepted arc. When I pulled that angle out to the edge of the circle, I made it smaller, so it became half of the measure of the intercepted arc. Well, what I'm doing it now is I'm pulling it even further back. And I want you to think of this distance here around this circle as A degrees. And I want you to think of this distance here as B degrees. Because what we're going to do is we're going to find the difference between those 2 arcs, and we're going to divide it by 2 to figure out this angle measure. And this A minus B divided by 2 is the same thing that happens for all 3 of these scenarios. If you call this arc the long way around, A, and you call this arc inside here, B, A minus B divided by 2 is going to get you this angle measure. If you have this angle measure here, B, and this angle measure here, A minus B divided by 2 is going to give you the angle measure. Whether you have 2 secants, 2 tangents, or a secant and a tangent, it's going to be these 2 arcs subtracted, divided by 2. Now the one thing I want to make sure that you know, and that is about this one is a little bit different. Because these are 2 tangents, sometimes you'll need to refer to this angle measure as 360 minus A. Because it's tangents, these 2 evenly, not evenly, but these 2 divide the circle up completely. A and B don't leave anything left out. Notice the secant line doesn't include this area outside of its point. But this circle here, the entire circle is included. So sometimes you'll see B represented as 360 minus A. Those are your circle angle rules. And those are the ones that you're going to end up using when you're finding these different values. So if the circle, if the intersection is inside of the circle, it's A plus B divided by 2, or the average. If it's outside of the circle, it's A minus B divided by 2. And of course, you know that the further that the angle goes outside the circle, the smaller it gets. That's for our angles. All right, now we're going to shift gears and talk about segments. So when we have this same scenario, as far as 2 chords inside, 2 secants, intersecting outside, tangent, secant, outside. Now keep in mind, you're like, wait a minute, what's missing? What about two tangents? Remember, we already have that. Because if I have a circle and two tangent lines intersecting outside, didn't we already talk about how they're going to be congruent? So when we talk about these four angle relationships, two chords inside and this, these two tangents we've already covered because we know they're congruent. All right. For these two chords intersecting inside the circle, if I label things A and B and C and D, the product of those pieces is constant. So A times B is equal to C times D. This piece times piece is equal to the piece times piece. A times B is equal to C times D. If I have two secants intersecting outside the circle, I take this intersection, so my A is this piece here, and my B is now this whole piece. So it's still A times B is equal to C times D, but my A and C are outside of the circle, and my D and B are going to be that whole length. So it's still AB equals CD. Same thing here. If I'm talking about my A, and I'm talking about my C, this D here is this whole piece, but this A doesn't have another piece, so we square in. So it's still AB is equal to CD, but instead of AB, because I only have one point of intersection, it's going to be A squared is equal to CD. So whether you like the picture, the rule, or the words, that's what tells you how to solve for each individual piece. So what I'd like you to do is spend some time thinking and working on these circles. Flip back and forth. Your entire homework should be flip, 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 flip as you look back and find the rules. And we'll talk about it when we see you next.